Hello everyone, welcome back. So this time we're going to be going over gas pressure. Did just regular pressure last time, that's pressure usually due to a force. Gas pressure is always due to a gas. We have a gas, it wants to expand, it can't, there's a pressure. Okay, let's get to it. Always hit this button, and there we go. Okay, so gas pressure is the force of countless microscopic collisions. And they're distributed over the surface of containers. So that surface has to stop those collisions. It applies a force, making them bounce back. And all of that together, all that force together over the surface of the container is that pressure. So it's still force over an area. It's just we can't really measure the force. We can't okay, let's get a little scale and measure how much that atom changed. We can't really do that. There's millions of atoms, millions of molecules. It's not going to work. So what do we do? Well, we use the ideal gas law. You're like, okay, ideal gas law. That sounds like it's only for ideal things. You are correct. It's only for ideal things. But it can still help us out. Now, in this class, if you have a gas and we're asking for pressure, you're going to need to use the ideal gas law. But in real life, there are places where the ideal gas law just does not work. It is not effective. It is not useful. So you have to make sure you know what you're using. But in this class, probably Chemistry 151, you're probably okay. Chemistry 152, you might have to worry about it. But let's forget about that for now. For now, let's keep on talking about the ideal gas law. So it's PV equals nRT. It's one of those ones that might be good to memorize. You don't have to, but it could really help. So PV equals nRT. So pressure times volume is equal to the number of moles times the ideal gas constant, which is 8.314 joules per mole Kelvin. There's a bunch of those. They're all the same thing, just in different units. Look at Wikipedia. You can write them all down in your conversion sheet if you want to, so just have them ready. And then temperature. Okay, so what's the importance of each of these little points? Well, pressure is what the gas or the container feels. The gas is pressing on the inside of the container, trying to get out. It's causing a pressure. The container is pushing on the gas and keeping it from moving. So both are causing a pressure on the other. V is the volume. The more you increase the volume, the more room there is for the gas to move before collision. Also, there's more surface area, if you want to think about it that way, for the collisions to be averaged over. More surface area, you have more room to collide, but also there's just so much more area, so it gets reduced. N is simply the number of moles. You got more stuff to collide. You see all those little dots in there. There's a lot of them. So more stuff to collide. And then finally, T is for temperature. It just means that stuff is going to hit harder. Because remember, temperature is the average kinetic energy of the molecules of the atoms in your device. So it's the average kinetic energy. Now, because of that, it means that the hotter they are, the more hard they're going to hit. And so if they hit harder, that's more force, more pressure. Kind of get the point there. Now, all these things are connected together. So if you have a certain situation, it's at 1 atmosphere, and I increase the volume, keeping everything else constant, the pressure is going to go down. If I decrease the volume, keeping everything else constant, the pressure is going to go up. They're all connected. And so you can look at those things, see this relationship, and see how it's going to change. So keep that in mind. Think about that. It can really help you out. Okay, so we're going to stop here for gas pressure, but next time we're going to talk about a very important fact about the temperature. So don't forget, go check it out. I'll see you next time. Bye-bye.